There is something inside you right now that you have never seen. You have felt it. You have watched it bead on the surface of a paper cut. You have tasted it by accident when you bit your lip as a child, but you have never truly seen it doing what it does. Right now, this very second, 5 liters of it are racing through you at a speed that would surprise you. Through arteries thinner than a pencil. Through capillaries so narrow that your blood cells have to squeeze through them, single file, bending and folding like passengers on a packed train, each one carrying a cargo of oxygen that your brain will consume in the next 4 seconds. If it stops, you stop, not in an hour, not in 10 minutes, in seconds. Your consciousness, your personality, every thought you have ever had, every memory of every person you have ever loved, all of it depends on this one liquid continuing to move in a circle that it has been tracing since the day you were born. And here is the thing that should keep you up at night, but probably never has. Nobody fully understands it. Oh, we know the basics. We can name the components. We can type it and test it and transfuse it from one human to another. We can separate it into red cells and white cells and platelets and plasma. We can freeze it and store it and ship it across oceans in temperature-controlled containers. We have mapped the genes that determine its type and catalogued the antigens that dot the surface of every red blood cell like molecular name tags. But underneath all of that knowledge, underneath the charts and the textbooks and the Nobel Prizes, there are questions that nobody has answered. Questions that have haunted scientists for decades. Questions so strange and so fundamental that when you hear them for the first time, you will never think about the liquid inside your veins the same way again. Why do blood types exist at all? What evolutionary pressure could possibly have created a system where one human's blood is poison to another human's body? Why would nature build a mechanism that makes a mother's immune system attack her own unborn child? And why, out of all the primates on Earth, are humans the only ones walking around with a blood type so anomalous that it shouldn't exist according to everything we know about evolutionary biology? Tonight I am going to tell you the entire story, from the first moment a human being noticed that blood was more than just red liquid, through the centuries of wrong theories and fatal experiments, through the discovery that saved millions of lives and the mystery that discovery revealed, through the ancient migrations and population bottlenecks that shaped the blood running through your veins right now, all the way to the question that modern genetics still cannot answer. Why does your blood type exist? What is it for? And what does it tell you about where you came from? But I need to warn you about something before we start. This story has a strange quality to it. The deeper you go, the more questions appear. Every answer opens a new door, and behind every door is another corridor. And at the end of every corridor is another question that nobody expected. Scientists have been walking these corridors for over a century, and they still have not reached the end. Some of them suspect there is no end. That blood, this ancient substance that we share with every vertebrate that has ever lived on this planet, holds secrets that we are not yet equipped to understand. So settle in. Let the weight of the day leave your body. Let your breathing slow. And let me take you somewhere you have never been, inside the 5 liters of mystery that are keeping you alive right now. We need to start with something that seems obvious, but is not obvious at all. We need to start with the color. Blood is red. Everyone knows this. But for most of human history, nobody knew why. And the question of why blood is red turns out to be one of those deceptively simple questions that, when you pull the thread, unravels into something enormous. Blood is red because of iron, specifically because of hemoglobin, a protein that sits inside every red blood cell and contains 4 atoms of iron, arranged in a molecular structure so elegant that when chemists first figured it out in the 20th century, some of them described it as beautiful. Each hemoglobin molecule is folded into a precise 3-dimensional shape that creates a pocket, and in that pocket sits an iron atom. And that iron atom does something remarkable. It grabs oxygen. When blood passes through your lungs, the hemoglobin molecules open their pockets, and each iron atom latches onto a molecule of oxygen. The chemical bond between iron and oxygen changes the way the molecule absorbs light, and that change makes the blood bright red. When the blood reaches your tissues and the oxygen is released, the bond changes again and the blood becomes darker, a deep crimson that looks almost blue through the skin of your wrist, which is why people used to believe that venous blood was actually blue. It is not blue. It has never been blue. The blue appearance is an optical illusion created by the way light penetrates skin and the way different wavelengths are absorbed and scattered by tissue. But that illusion persisted for centuries, and it fed into one of the most consequential myths in human history. The myth of blue blood. The idea that aristocrats, nobles, royals, that their blood was literally, physically different from the blood of common people. That something in their veins set them apart, made them special, made them worthy of power. We will come back to that myth later because it connects to something real and something disturbing. But first, we need to go further back, much further back, to a time before anyone understood blood at all, to a time when blood was not a medical subject. It was a sacred one. Because here is something that most people do not realize. For the vast majority of human history, blood was not studied. It was worshipped. It was feared. It was offered to gods. It was used in rituals that predate writing by tens of thousands of years. The oldest human relationship with blood is not scientific. It is spiritual, and that spiritual relationship shaped everything that came after. Think about what blood looks like to someone who has no framework for understanding biology. It is the one substance that is always inside you and that you only see when something has gone wrong. When you are injured, when you are in danger, when the boundary between your body and the world has been breached, blood appears at moments of violence, of birth, of death. It appears when the barrier between inside and outside breaks down, and it does something that no other body fluid does. It changes. It starts as a liquid, bright and flowing, and then within minutes it thickens, darkens, congeals into something solid. It transforms before your eyes, from life to not life, from flow to stillness. To an ancient mind, this transformation was not chemistry, it was magic. It was evidence that blood contained something, some vital force, some essence that departed when the blood left the body and stopped moving, the redness fading, the warmth cooling, the liquid becoming solid. Every one of these changes was a sign that something invisible was leaving, something essential, something that could not be recovered once it was gone. This is why virtually every ancient culture on Earth developed rituals around blood, not because they were primitive or superstitious, but because they were observant. They saw what blood did. They saw that living things had it and dead things did not. They saw that losing too much of it meant losing everything. And they drew the most logical conclusion available to them. Blood was life itself, not a metaphor for life, not a symbol of life, life, the actual substance of being alive. The Egyptians believed that blood carried the K, the life force that animated the body and that departed at death. They preserved the bodies of their dead with extraordinary care, removing organs, drying tissues, wrapping everything in linen. But they did not preserve the blood. They could not. Blood defied preservation. It clotted, it darkened, it rotted. Whatever the Ka was, it left the blood first. This told the Egyptians something important. Blood was the most temporary, most fragile vessel of life. It could not be stored or saved. It existed only in the living, flowing moment. Once it stopped, the Ka moved on. The Hebrews took this understanding and codified it into law. The Torah states explicitly that the life of the flesh is in the blood. This was not poetry. This was legal doctrine. Because the life was in the blood. Blood was sacred. It belonged to God. You were forbidden to consume it. When an animal was slaughtered for food, its blood had to be drained completely and poured onto the ground as an offering. To eat blood was to consume life itself, to take something that belonged to the divine and claim it for yourself. This prohibition shaped Jewish dietary law for 3,000 years and eventually passed into Islamic tradition as well. The Greeks had a different framework, but arrived at similar conclusions. Hippocrates, the father of Western medicine, developed the theory of the 4 humours, 4 fundamental fluids that governed health and personality. Blood was one of the 4, along with phlegm, yellow bile, and black bile. In this system, blood was associated with warmth, moisture, spring, air, and the sanguine temperament, cheerful, optimistic, sociable, brave. Too much blood made you feverish and reckless. Too little made you cold and weak. The goal was balance, and the primary tool for achieving that balance was bloodletting, deliberately cutting a vein and allowing blood to flow out of the body until the humours were restored to equilibrium. And here is where the story takes a dark turn, because bloodletting was not a fringe practice. It was not a folk remedy used by uneducated villagers. It was the single most common medical procedure in the Western world for over 2,000 years. From the time of Hippocrates in the 5th century BCE until well into the 19th century CE, doctors bled their patients for virtually every ailment imaginable: fever, infection, headache, insomnia, depression, headache, insomnia, depression, inflammation, pneumonia, plague. If you were sick, the first thing your doctor was likely to do was open a vein and watch your blood pour into a bowl. The tools were specific and varied. The lancet, a small sharp blade designed for precise cuts; the fleam, a wider blade for faster flow. And most disturbingly, leeches, living, blood-sucking worms applied to the skin in carefully chosen locations. The leech trade was so enormous that in the 19th century, European leech populations were nearly driven to extinction by medical demand. Hospitals kept jars of them the way modern pharmacies keep bottles of pills. George Washington, first President of the United States, almost certainly died from bloodletting. In December 1799, he developed a severe throat infection. His doctors, following standard practice, bled him 4 times in 12 hours, removing an estimated 5 pints of blood, roughly 40% of his total blood volume. He died the next morning. Whether the infection would have killed him regardless is debatable. What is not debatable is that removing 40% of his blood did not help. And this is the thing that amazes me about the history of blood. For 2,000 years, the most educated, most sophisticated, most well-intentioned physicians in the world were draining the very substance that kept their patients alive, and they were doing it because they believed they understood what blood was and what it did. They were wrong, catastrophically, fatally wrong, but their wrongness was not random, it was systematic. It was based on a theory, the humoral theory, that was internally consistent, logically coherent, and supported by centuries of tradition. The theory made sense, it just happened to be completely incorrect. And because it made sense, nobody questioned it. For 2,000 years. I want you to sit with that for a moment, not because it is a story about ancient ignorance. It is not. It is a story about the nature of knowledge itself, about how the things we are most confident about, the things that seem most obviously true, can be the things that are most dangerously wrong. The doctors who bled George Washington were not fools. They were doing exactly what their training and their experience told them to do. They were following the science of their time, and they killed him. This should make us humble. Not about blood specifically, but about everything. About all the things we currently believe that future generations will look back on with the same horror that we feel when we read about 18th century bloodletting. What are we doing right now? Confidently, systematically, with the best intentions, that is completely wrong. We do not know. That is the point. We never know until later. But I am getting ahead of myself. We are still in the era before anyone understood what blood actually was. Before anyone knew that it came in types. Before anyone realized that the red liquid flowing through your veins and the red liquid flowing through mine might be as different as 2 separate languages. And the story of how we discovered that difference begins not with a breakthrough, but with a catastrophe. If you are listening to this and starting to feel your eyelids get heavy, good. That is exactly what is supposed to happen. You are safe. You are warm. The story will carry you wherever you need to go. You do not need to remember any of this. We do not need to stay awake for the important parts, because all the parts are equally important and none of them require your conscious attention. Just let the words flow over you like the blood flows through you. Steady. Continuous, ancient, reliable. And if you are still here tomorrow, and I hope you are, maybe leave a comment telling me where in the world you are listening from tonight. Not because I need to know, but because there is something quietly magical about the idea that at this exact moment, someone in Seoul and someone in Sao Paulo and someone in a small town in Norway are all lying in the dark, listening to the same story about the same substance that is keeping all of them alive simultaneously. That is a kind of connection that blood itself would understand. Different types, different bodies, different continents, but the same ancient purpose. The same refusal to stop flowing. Now, let me tell you about the first blood transfusion, because what happened in Paris in 1667 is one of the strangest, most disturbing and most consequential experiments in the history of medicine, and it starts with a sheep. Jean-Baptiste Denis was not a physician. He was a mathematician and a philosopher who had become fascinated by the work of William Harvey, the English doctor who had finally, in 1628, figured out that blood circulated through the body in a continuous loop. Harvey's discovery was revolutionary. For 2,000 years, doctors had believed that blood was produced by the liver and consumed by the organs, like fuel being burned. Harvey proved that blood went around and around, pumped by the heart, flowing out through the arteries and back through the veins in an endless circle. This meant that the body did not use up blood the way a fire uses up wood. It recycled it. And if it recycled it, then maybe, just maybe, you could add more. You could put blood in from outside. You could transfuse. Denis decided to try, not human to human, because that seemed too dangerous, too unpredictable. Instead, he chose a donor that seemed safer, a sheep. His reasoning was that animal blood, being purer and less corrupted by human vice, would be healthier than human blood. This was not unusual thinking for the 17th century. The humoral theory held that diet, behavior, and moral character all affected the quality of your blood. A gentle, innocent lamb would naturally have gentler, more innocent blood than a person corrupted by alcohol, anger, or sin. On June 15, 1667, Denis transfused about 12 ounces of lamb's blood into a 15-year-old boy who had been bled repeatedly by other doctors and was weak, pale, and feverish. The boy survived, not because the lamb blood helped, but because 12 ounces was not enough to trigger a fatal immune reaction in most cases, and the boy's body simply absorbed what it could and destroyed the rest. Denis was thrilled. He tried again on a healthy volunteer with similar apparent success. Then he tried on a man named Antoine Mauroy. Mauroy was mentally ill. He was violent, unpredictable, and had been brought to Denis by his wife, who was desperate for any treatment that might calm him. Denis transfused calf's blood into Mauroy. The first transfusion seemed to work. Mauroy became calmer, more lucid. Denis, excited, performed a second transfusion. This time Mauroy's body reacted violently. He developed a high fever. His heart raced. His urine turned black, a sign that his red blood cells were being destroyed and the hemoglobin was being filtered through his kidneys. He survived the acute reaction, but days later he died. His wife accused Denis of murder. The case went to court. Denis was eventually acquitted, and there is evidence that Mauroy's wife may have actually poisoned him with arsenic, possibly to collect on debts. But the damage was done. The French Parliament banned blood transfusion. The Royal Society in England followed. The Pope issued a papal edict against the practice. For the next 150 years, blood transfusion was essentially illegal across Europe. 150 years. Think about how many people died during that century and a half who might have been saved by a transfusion. Battlefield casualties who bled out within reach of other soldiers whose blood could have saved them. Women who hemorrhaged during childbirth while doctors stood by helplessly. Children who lost blood from injuries and simply faded away because nobody was allowed to replace what they had lost. All because of one failed experiment with calf blood and a murder trial in 17th century Paris. But the ban also prevented something else. It prevented the discovery that would have saved all those lives. Because as long as nobody was doing transfusions, nobody had any reason to discover that blood came in types. The clue was right there, hiding in plain sight. Some transfusions worked and some did not. Some recipients survived and some died in agony. The pattern was there, waiting to be noticed. But you can only notice a pattern if you are looking for one, and the ban ensured that nobody was looking. The breakthrough, when it finally came, happened in a laboratory in Vienna in 1901, and it happened almost by accident. Karl Landsteiner was not trying to save lives. He was trying to solve a puzzle. He had noticed that when he mixed blood samples from different people, sometimes the red blood cells clumped together, and sometimes they did not. This clumping, called agglutination, was well known. Other scientists had seen it, but they had dismissed it as a random artifact, a meaningless side effect of mixing blood outside the body. Landsteiner did not dismiss it. He was the kind of scientist who could not leave a puzzle unsolved. He collected blood samples from his colleagues, separated the red blood cells from the serum, and systematically mixed each person's cells with each other person's serum in every possible combination. Then he sat down and looked at the results. Some combinations clumped, others did not. And the pattern was not random. It was perfectly, beautifully, terrifyingly consistent. Every person's blood fell into one of three groups, which Landsteiner labelled A, B, and C. A fourth group, AB, was identified shortly afterward by two of his students. The logic was elegant. People with type A blood had A antigens on their red blood cells and anti-B antibodies in their serum. People with type B had B antigens and anti-A antibodies. People with type AB had both antigens and no antibodies. And people with type O, Landsteiner's original type C, had no antigens and both antibodies. This meant that if you transfused type A blood into a type B person, the recipient's anti-A antibodies would attack the donor's A antigens, causing the red blood cells to clump together, block blood vessels, and trigger a cascade of organ failure that could kill within minutes. But if you matched the types correctly, A to A, B to B, the transfusion would work. The blood would flow. The patient would live. Landsteiner had solved the puzzle that had killed Antoine Marois and countless others. He had discovered why some transfusions worked and some did not. He had found the key that would unlock the door to modern transfusion medicine, to blood banks, to battlefield surgery, to the routine medical procedures that save millions of lives every year. He received the Nobel Prize in 1930. He deserved it. But even Landsteiner himself would have been the first to admit that his discovery raised more questions than it answered. Because the ABO system was not the end of the story. It was the beginning, and behind it, waiting to be found, was something even stranger. The Reif factor. And the Reif factor is where this story goes from remarkable to genuinely unsettling. Because the Reif factor does not follow the rules. It does not behave the way blood types are supposed to behave. It creates a paradox that should not exist according to everything we understand about evolution and natural selection. A paradox that has haunted scientists for 80 years and that, despite all our advances in genetics and molecular biology, we still cannot fully explain. But before I tell you about the Reif factor, I need to tell you something about the man who discovered it, because Karl Landsteiner was not finished. His ABO discovery in 1901 was the work of a young researcher at the beginning of his career. The rediscovery, 36 years later, was the work of an older, wiser, more cautious scientist who understood that what he was looking at was not just a new blood type. It was a window into something much deeper, something about human evolution, something about where we came from. In 1937, working at the Rockefeller Institute in New York with his colleague Alexander Wiener, Landsteiner was conducting experiments with blood from rhesus macaque monkeys. The experiments were routine. They injected monkey blood into rabbits and guinea pigs to see what antibodies the animals produced. Standard immunology. The kind of work that fills laboratory notebooks with predictable results. Except the results were not predictable. When they tested the antibodies produced by the rabbits against human blood samples, something happened that should not have happened. The antibodies reacted with about 85% of the human samples, causing agglutination, but 15% of the samples showed no reaction at all, nothing. As if those blood cells were invisible to the antibodies. Landsteiner knew immediately that he was looking at another blood group system, another layer of classification hidden beneath the ABO types he had already discovered. He called it the Reif factor, after the rhesus monkeys whose blood had helped reveal it. If you had the marker, you were race positive. If you did not, you were RSE, Rive negative. And here is where the strangeness begins. Because the RAS factor was not like the ABO system. The ABO system made sense. You could find versions of it in other primates. It was ancient, probably evolved to help protect against certain pathogens. Different blood types might have offered different resistance to different diseases, creating a selective pressure that maintained the diversity. But the RAF factor was different. The protein it marked, the D antigen, was so fundamental that virtually all mammals carried some version of it. Primates had it, dogs had it, cats had it, mice had it. The evolutionary lineage of this protein stretched back hundreds of millions of years. It was as basic and as universal as having red blood cells at all. So why did 15% of humans not have it? Every chimpanzee has the RE protein. Every gorilla. Every orangutan. Every monkey species ever tested. It is universal across our entire primate family tree. And then you get to humans, and suddenly 15% of us are missing it. Not damaged, not mutated into a different form, just gone. As if someone had reached into the genome and deleted it. This was the puzzle that Landsteiner left behind when he died in 1943, just 6 years after the discovery. He never got to see how deep the mystery actually went. Because the RAF factor was not just a laboratory curiosity. It was a killer, and the way it killed was unlike anything else in human biology. A woman with RAS negative blood marries a man with RAS positive blood. She becomes pregnant. The baby inherits its father's RAS positive blood type. And now you have something that evolution should never allow. A mother whose immune system is programmed to attack her own child. It does not happen with the first pregnancy. Not usually. During the first pregnancy, the mother and the baby's blood are kept mostly separate by the placenta. But during birth, when the placenta separates from the uterine wall, small amounts of the baby's RT's blood leak into the mother's RT's negative bloodstream. Her immune system encounters the D antigen for the first time. It does not recognize it. It treats it as a foreign invader, and it begins producing antibodies. Those antibodies are tiny, small enough to cross the placenta, and they wait. They circulate in the mother's blood, patient, vigilant, looking for the enemy they were designed to destroy. If the mother becomes pregnant again, and if the next baby is also RAS positive, those antibodies cross into the baby's bloodstream and begin attacking. They latch onto the baby's red blood cells and mark them for destruction. The baby's body tries to compensate, producing red blood cells faster and faster, but it cannot keep up. The baby becomes anemic, its organs begin to fail, its body swells with fluid. In the worst cases, the baby is born dead. This is called hemolytic disease of the newborn, and before modern medicine developed a treatment for it, it killed thousands of babies every year. First pregnancies were usually safe. Second pregnancies were risky. Third, fourth, fifth pregnancies became increasingly dangerous. Some women lost baby after baby, never understanding why their bodies kept betraying them, never knowing that the answer was written in their blood. The treatment, when it came in 1968, was brilliantly simple. An injection called reimmune globulin, given to Rh-negative mothers after delivery, that prevents their immune system from ever recognizing the baby's Rh-positive blood cells. The antibodies in the injection find and destroy the fetal blood cells before the mother's immune system can react to them. No reaction, no memory, no antibodies, no danger to the next baby. It works. It has saved millions of lives. It is one of the great triumphs of modern medicine. But it does not answer the question, why does this happen at all? Evolution is supposed to optimize reproduction. That is the single most powerful force in all of biology. Traits that help you reproduce spread through the population. Traits that hinder reproduction are eliminated. This is not a suggestion. It is a law. It is the fundamental mechanism by which life on Earth has operated for 4 billion years. And yet here is a trait, Rh-negative blood, that actively sabotages reproduction. That causes mothers' bodies to attack their own unborn children. that killed thousands of babies every generation for thousands of years before modern medicine intervened. Natural selection should have eliminated Rh-negative blood from the human population within a few hundred generations. It should have been driven to extinction by the sheer reproductive disadvantage of carrying it. But it was not eliminated. It persisted. In some populations it thrived. Among the Basque people of northern Spain and southern France, Rh-negative blood reaches frequencies of 30 to 35%. 1 in 3 Basque people carries a blood type that, without modern medicine, would have killed a significant percentage of their children. How is this possible? There are only 2 explanations. Either Rh-negative blood provides some advantage, some benefit so significant that it outweighs the reproductive cost, something that makes IAR-negative individuals more likely to survive, or healthier, or more resistant to some disease, or better adapted to some environment in a way that compensates for the baby's loss to hemolytic disease. Or the standard model of evolution is incomplete, and there is something happening in human blood that we do not understand, something that operates outside the normal rules, something that the textbooks have not accounted for. Scientists have been looking for that advantage for 80 years. They have tested Rh-negative individuals for resistance to malaria, to plague, to influenza, to toxoplasmosis, to every pathogen they can think of. They have looked at immune responses, at disease susceptibility, at longevity, at fertility, and they have found hints, whispers, suggestions, but nothing definitive. Nothing that would explain why a blood type that kills babies would persist at 35% in any population. The mystery remains open, the corridors keep branching, the doors keep multiplying, and behind every door, the same question, whispered in the dark by every scientist who has ever stared at a Rh-negative blood sample under a microscope. Where did this come from? And why is it still here? We are going to follow those corridors tonight. We are going to trace Rh-negative blood back through human history, through ancient migrations and genetic bottlenecks and population crashes that nearly wiped our species off the face of the earth. We are going to look at the geographic distribution and ask why this blood type follows a pattern that no other blood type follows. We're going to examine the theories, from the plausible to the extraordinary to the genuinely strange, and we are going to end up somewhere that I think will surprise you. Not with an answer because there is no final answer yet, but with a new way of thinking about the liquid that is flowing through you right now as you lie in the dark and listen to these words. Your blood is not just a medical category. It is a historical document, a genetic archive, a record of every catastrophe and migration and random accident that your ancestors survived over the last 300,000 years. And the story it tells is stranger than anything you have ever been taught in a biology class. But we will get there, one step at a time, one discovery at a time, one mystery at a time. And if sleep takes you before we reach the end, that is perfectly fine. The blood will keep flowing. The story will keep unfolding. And tomorrow night, or the night after, you can come back and pick up where you left off. Because this story has been waiting for 80 years. It can wait one more night for you. The next part of the story takes us somewhere unexpected, not to a laboratory or a hospital or a royal court, to a mountain range, a small, stubborn, ancient mountain range that sits on the border between Spain and France and that holds, in the blood and language and bones of its people, a mystery that has baffled scientists for over a century. The Pyrenees, home of the Basque people, the population with the highest concentration of Rh-negative blood anywhere on Earth, and the people who, in every possible way, should not exist, because the Basques are impossible, not biologically impossible, culturally, linguistically, genetically impossible. They are a contradiction wrapped in a mountain range, and what their blood tells us about human history is going to change the way you think about your own. The first thing you need to know about the Basques is their language, Euskara. Say it slowly, Euskara. It sounds like nothing else you have ever heard. Because it is nothing else. It is a language isolate, the only surviving pre-Indo-European language in Western Europe. Every other language spoken on the continent, Spanish, French, English, German, Italian, Portuguese, Russian, Greek, all of them belong to the same vast language family, Indo-European. They are cousins. Distant cousins in some cases, but cousins nonetheless. They share roots and grammar structures and vocabulary that can be traced back to a common ancestor language spoken somewhere on the steppes of Central Asia about 5,000 or 6,000 years ago. Euskara shares none of this. It has no known relatives, no sister languages, no parent language that linguists have been able to identify. It stands alone, a linguistic island, in a sea of Indo-European tongues, and nobody knows where it came from or how it survived when every other pre-Indo-European language in Western Europe was swept away by the great migrations that reshaped the continent. This linguistic isolation matches the genetic isolation. DNA studies have shown that the Basques are one of the most genetically distinct populations in Europe. They carry genetic markers that are rare or absent in surrounding populations. They show evidence of deep ancestral roots in the region, possibly stretching back to the earliest modern human inhabitants of Europe, the Cro-Magnons who arrived 40 to 45,000 years ago. And they carry Rh mis dolly at a rate of 30 to 35%, 1 in 3, compared to 15% for Europe as a whole, compared to less than 1% for most of Africa and Asia, compared to effectively 0 for indigenous populations of the Americas and Australia. Why? The conventional explanation is geographic isolation. The Pyrenees are a natural barrier. The Basques lived in the mountains, protected from the waves of migration that swept across the rest of Europe. The Indo-European speakers who arrived with their bronze weapons and their horses flowed around the mountains rather than through them. The Basques kept their language, kept their customs, kept their genetics, kept their blood. And this explanation works. Up to a point. Geographic isolation does preserve genetic traits. Small populations in isolated areas do show unusual frequencies of certain genes. This is basic population genetics, but it does not explain why RAS-negative blood would be so common in the first place. Isolation preserves what already exists. It does not create. Something put RAS-negative blood into the Basque population at high frequencies, and then isolation preserved it. But what put it there? And when? Some researchers believe the answer lies in the Ice Age. During the last glacial maximum, roughly 20,000 years ago, Europe was a frozen wasteland. Ice sheets covered Scandinavia and most of Britain. Glaciers covered Scandinavia and most of Britain. Glaciers fill the alpine valleys. The habitable zone shrank to a narrow band along the Mediterranean coast and a few sheltered refugia in the south. The Pyrenees region was one of those refugia. Small populations of humans survived in the mountains and valleys of what is now the Basque country, sheltered from the worst of the cold, eking out an existence on whatever resources the landscape provided. These were small populations, maybe a few hundred individuals, maybe a few thousand at most, and in small populations, genetic drift is enormously powerful. Random fluctuations in gene frequency that would be smoothed out in a large population can become amplified in a small one. A trait that starts at 5% can drift to 30% in a few dozen generations purely by chance. No selective advantage needed, just the mathematical reality of random sampling in small groups. This is called the founder effect, and it may explain the high Rh negative frequency among the Basques. A small founder population, isolated by ice and mountains, carrying Rh negative blood at moderate frequencies. Genetic drift pushing those frequencies higher over thousands of years. And then when the ice retreated and the rest of Europe was repopulated, the Basques remained in place, still carrying their elevated Rh negative frequencies, while the incoming populations diluted the trait elsewhere. It is a clean explanation. It is a plausible explanation. But it is not a proven explanation, and there are details that do not quite fit, because the Basques are not the only population with elevated Rh negative blood. The Berbers of North Africa show similar elevations. The Irish, the Scots, the Welsh, the Bretons, all the Celtic fringe populations of Atlantic Europe show ROS negative frequencies significantly above the continental average. And here is what is really interesting. When you map RRRH negative blood across Europe, you do not get a random scatter, you get a gradient, a clear directional pattern that starts at its highest point in the Pyrenees and spreads outward, diminishing as you move east. Western Europe is high. Central Europe is moderate. Eastern Europe is lower. Asia is very low. Africa is near zero. This gradient does not look like genetic drift. Drift is random. This gradient looks like a wave, like something that originated in one place and spread outward, or like something that was once widespread and was pushed back, retreating to the west, to the mountains, to the Atlantic fringe, as new populations moved in from the east and diluted it. Which possibility is correct changes everything about what Rh-negative blood means. If it spread outward from a single origin, then it is a relatively recent mutation that happened to arise in Western Europe. If it was once widespread and retreated westward, then it is ancient, much more ancient than anyone currently suspects. And the populations that carry it at high frequencies, the Basques, the Berbers, the Celtic peoples, are not anomalies. They are survivors, remnants of an older genetic landscape that was overwritten everywhere else by the great migrations of the last 10,000 years. I do not know which of these possibilities is true. Nobody does. The evidence points in both directions simultaneously, like a compass needle spinning between two poles, and that uncertainty is not a failure of science. It is the frontier of science, the place where knowledge ends and questions begin. The dark space at the edge of the campfire, where the shapes are ambiguous and the sounds could be anything. But there is one more piece of this puzzle that I need to tell you about before we move on. One more connection that makes the geography of Rd-D blood even more mysterious, and it involves not blood, but bones. In 2010, scientists sequencing the Neanderthal genome made a discovery that shocks the field. Modern Europeans carry between 1 and 4% Neanderthal DNA. We interbred with them. Not once, not as a fluke, but repeatedly over thousands of years across multiple locations in Europe and the Middle East. The genes we inherited from Neanderthals are not junk. Some of them are active. Some of them are active our immune systems, our skin, our hair, our susceptibility to certain diseases. And some researchers have wondered whether any of them affect our blood. The Neanderthals lived in Europe for over 200,000 years before modern humans arrived. They were adapted to the European environment in ways that we were not. They had larger brains, more robust bodies, lighter skin, and immune systems tuned to European pathogens. When we interbred with them, we acquired some of those adaptations. It is possible, though not proven, that some of the genetic variation in our blood type systems, including the RAS system, has roots in that ancient mixing. If Rh-negative blood has a Neanderthal connection, it would explain several things. It would explain why it is common in Europe but rare elsewhere, because Neanderthal admixture is highest in Europeans. It would explain the geographic gradient, because Neanderthal admixture also follows a gradient, highest in Western Europe, diminishing as you move east and south. And it would explain the Basque connection, because the Basques, with their deep European roots, might carry more of that ancient admixture than populations that arrived later. But this is speculation. We do not have Neanderthal blood to test. We cannot extract archetype from ancient DNA with current technology, at least not reliably. The connection remains a hypothesis, tantalizing but unproven, another corridor branching off into the dark. And that is where I want to leave you for now. Not with an answer, but with a question. Not with certainty, but with wonder. The blood inside you carries information that we are only beginning to read. It tells a story that stretches back not just centuries or millennia, but hundreds of thousands of years. A story of migrations and bottlenecks and ice ages and interbreeding and catastrophes and survivals that, taken together, make you one of the most improbable things in the universe. A living being. A conscious mind. An inheritor of every genetic experiment that your ancestors' bodies ever conducted. Your blood type is one small chapter in that enormous story. But even that one small chapter contains more mystery, more complexity, more unanswered questions than most people encounter in a lifetime of asking. And the story is not over. It continues flowing, circulating, carrying oxygen and information, and ancient secrets through 5 liters of liquid that you will never fully understand, but that will never, not for 1 second, stop keeping you alive. So let it flow, let it do its work. Let your body handle the chemistry and the immunology and the oxygen transport while your mind does something much simpler, something much older, something that your ancestors did every night for 300,000 years. Close your eyes. Breathe slowly. And let the oldest substance in your body carry you gently into sleep. The story will be here when you wake up. It has been here for 80 years. It has been here for 40,000 years. It has been here since the first Rh-consecutive baby was born in a cave somewhere in Ice Age Europe, squalling and red-faced, and utterly unaware that the blood in its tiny veins contained a mystery that would outlast every empire, every religion, every scientific theory that humanity would ever produce. That mystery is still flowing, through the Basques in their mountains, through the Berbers in their deserts, through you, wherever you are, whatever type you carry, whatever secrets your hemoglobin is keeping tonight. Sleep now. The blood will keep its secrets until morning, and the morning will come. It always does. But you are not there yet. You are still here, in the dark, in the quiet, and the story is still flowing, like the blood itself. Steady, patient, ancient. And we have so much further to go. Because everything I have told you so far, the discovery of blood types, the Roche factor, the Basque mystery, the pregnancy paradox, all of that is just the surface, the visible layer, the part of the iceberg that breaks the water and catches the light. Beneath it, in the cold dark water where most of the mass sits invisible and silent, there is something much larger, something that connects your blood to events so old and so catastrophic that they nearly erased humanity from the face of the earth before we ever built a city or wrote a word or looked up at the stars and wondered what they were. We need to go back, not thousands of years, not tens of thousands. We need to go back nearly 1,000,000 years, to a moment in human history that most people have never heard of, a moment that should have been the end of the story, the moment when humanity almost did not make it. Scientists call it a population bottleneck. The word sounds clinical, dry, academic. It does not convey what it actually means. What it means is this. At some point in the deep past, the number of humans alive on Earth dropped so low that we nearly went extinct. Not locally, not in one region. Globally, the entire species, every man, woman and child on the planet reduced to a number so small that a single bad winter, a single epidemic, a single volcanic eruption could have finished us off forever. How small? The estimates vary. Some studies suggest the breeding population, the number of individuals actually producing the next generation, dropped to as few as 1,000. Other estimates are slightly more generous, putting the number at a few thousand. But even the most optimistic calculations agree on the basic picture. At some point in the last 1,000,000 years, probably multiple times, humanity was balanced on the edge of oblivion. One push and we would have been gone. Another dead-end branch on the evolutionary tree. Another species that almost was. We know this because of genetics. When a population crashes, it leaves a signature in the DNA, like a scar on a tree trunk that tells you about a fire that happened decades ago. A bottleneck leaves marks in the genome that persist for hundreds of thousands of years. Reduced genetic diversity, unusual clustering of certain traits, patterns of variation that can only be explained by a period when the population was so small that random chance overwhelmed natural selection. And human genetics bear those scars. Compared to other primates, we are astonishingly genetically uniform. Two chimpanzees from the same forest in West Africa are more genetically different from each other than any two humans on opposite sides of the planet. A man in Tokyo and a woman in Buenos Aires and a child in Nairobi are, genetically speaking, almost identical. The differences between them, the variations in skin color and hair texture and facial features and blood type are superficial, cosmetic, skin deep in the most literal sense. Underneath, the coat is remarkably, almost suspiciously similar. This should not be the case for a species that spans the entire globe. A species with 7 billion members spread across every continent and every climate should show much more genetic diversity than we do. The fact that we do not tells geneticists that at some point in our past, the diversity was stripped away, erased, like resetting a hard drive. The bottleneck wiped the slate nearly clean, and everything we see today, every variation between every human alive, has accumulated in the relatively short time since that bottleneck ended. Now here is where blood types enter the story. Because the ABO blood type system is ancient, much older than the bottleneck. It predates the split between humans and chimpanzees. It predates the split between humans and gorillas. The A and B blood types are so old that they exist in other primates, maintained across millions of years of separate evolution. Whatever purpose they serve, whatever selective pressure keeps them in the population, it is powerful enough to have survived multiple speciation events. But the R system is different. The distribution of Rh negative blood does not look ancient. It does not look like something that has been maintained by natural selection across millions of years. It looks recent. It looks like something that appeared after the bottleneck, or during it, or because of it. And this is where the story gets genuinely strange. Because if Rh negative blood is a product of the bottleneck, then it is not just a mutation. It is a scar. A genetic echo of the worst thing that ever happened to our species. A marker left behind by a catastrophe so severe that it reshaped the very composition of human blood. Think about what happens during a bottleneck. The population crashes. The gene pool shrinks. Traits that were rare in the large population can suddenly become common in the small one. Not because they are advantageous, but simply because of chance. If the few hundred individuals who survive the bottleneck happen to include a disproportionate number of people with a particular genetic variant, that variant will be overrepresented in all future generations. It becomes the new normal, not because it earned its place through competition and selection, but because it was lucky. It happened to be in the right bodies at the right time. This is called the founder effect, and it is one of the most powerful forces in genetics. It can take a trait that was vanishingly rare and make it common overnight, in evolutionary terms. It can take a trait that should have been eliminated and preserve it indefinitely. And it does all of this without any reference to whether the trait is good or bad or neutral. It just needs a small enough population and enough time. Could this be what happened with Rh negative blood? Could the bottleneck have amplified a rare variant, a deletion in the RHD gene that was present in a handful of the survivors, and pushed it to a frequency that natural selection alone would never have achieved? Could the 15% of modern humans who carry RARH negative blood be descendants of a specific group of bottleneck survivors who happened, by pure chance, to carry that deletion? The math works. The genetics work. The geography works, or at least it does not contradict. This is a plausible explanation that does not require ancient astronauts or lost civilizations, or any mechanism beyond well-understood population genetics. And yet it is also deeply unsatisfying, because it reduces one of the most distinctive features of human blood to an accident, a coin flip, a roll of the genetic dice during the darkest period in human history, and maybe that is what it is. Maybe the Rh negative mystery has no grand explanation. Maybe the universe does not owe us elegant answers. Maybe some things just happen, and the fact that they persist does not mean they were meant to persist. But there is another possibility. A possibility that does not get talked about much in the mainstream literature, but that some researchers have been quietly exploring for years. What if the bottleneck did not just amplify Rh negative blood by accident? What if the bottleneck selected for it? What if, during that period of extreme stress and near extinction, Rh negative blood provided some advantage that we have not yet identified? Something that helped its carriers survive when others did not. This is a harder hypothesis to test because we do not know what the bottleneck was. We do not know what caused the population crash. It could have been climate change, a sudden shift in temperature or precipitation that destroyed food sources. It could have been a supervolcano. The eruption of Toba in Sumatra about 74,000 years ago has been proposed as a candidate, though this theory is controversial. It could have been disease. It could have been something we have not even considered. If it was disease, then Rh negative blood might have provided resistance. Some pathogens interact with blood type antigens. We know this. Malaria, for example, interacts differently with different ABO blood types. If the bottleneck was caused or worsened by a pandemic, and if that pathogen happened to interact with the rice system, then Rh-negative individuals might have had a survival advantage. They might have been more likely to survive the pandemic, more likely to reproduce, more likely to pass their genes to the next generation. And when the bottleneck ended and the population began to recover, Rh-negative blood would have been enriched in the gene pool. Not by accident, but by selection. This is speculation. I want to be clear about that. There is no direct evidence linking a specific ancient pathogen to Rh-negative selection. But the logic is sound, and it would explain several things that the pure drift hypothesis does not. It would explain why Rh-negative blood persists at such high frequencies despite the reproductive cost of hemolytic disease. It would explain the geographic clustering if the pathogen was endemic to certain regions. And it would explain why natural selection has not eliminated a trait that kills babies, because the survival advantage against the pathogen outweighed the reproductive cost. But we cannot prove it. Not yet. Maybe not ever. The pathogen, if it existed, may have gone extinct long ago. The evidence may be buried too deep in the genetic record for current technology to retrieve. And so the question remains, hanging in the air like the smell of smoke from a fire that burned out 10,000 years ago. Was Rh-negative blood an accident or an adaptation? A scar or a shield? A random survivor of a random catastrophe, or a weapon forged in the hottest furnace our species has ever endured? I do not know. Nobody knows. And I think there is something beautiful about that. About the fact that the liquid flowing through your veins right now contains a mystery that the best minds in genetics have been trying to solve for 80 years and have not yet cracked. About the fact that your body carries information that predates every civilization, every language, every religion, every human institution that has ever existed, and that we still cannot fully read it. You are a walking archive, a living library. And some of the books on the shelves are written in a language we have not yet learned to translate. Let me take you somewhere else now, somewhere that seems completely unrelated to blood types and genetic bottlenecks, but that connects to everything we have been talking about in a way that will not become clear until later. I want to take you to the history of blood transfusion, not the early experiments with sheep blood that we already discussed. The modern history. The 20th century. The era when blood transfusion became not just possible but routine, and when the full complexity of what was flowing through our veins finally became visible. Because the story of blood in the 20th century is not a clean story of scientific progress. It is a story of war, of desperate innovation under impossible conditions, of discoveries made not in quiet laboratories, but on battlefields, in field hospitals, in the backs of ambulances bouncing over shell-cratered roads. It is a story of blood literally saving the world, and of the world nearly bleeding to death before it figured out how. The First World War changed everything about blood. Before 1914, transfusion was a curiosity. Landsteiner had published his blood type paper in 1901, but most doctors either did not know about it or did not believe it mattered. Transfusions were rare, risky, and often performed without typing, which meant that about 1 in 3 killed the patient. The war created a need that peacetime medicine had never faced. Thousands of young men, wounded by artillery shells and machine gun fire, were bleeding to death in trenches and field hospitals across France and Belgium. They did not need surgery. They did not need antibiotics, which did not exist yet anyway. They needed blood. Massive quantities of blood, delivered quickly, reliably, safely. The first problem was storage. Blood outside the body clots within minutes. You cannot pour it into a bottle and save it for later. You cannot stockpile it the way you stockpile bandages or morphine. If you wanted to give someone a transfusion, you needed a donor right there, right then, arm to arm, vein to vein. This made battlefield transfusion essentially impossible. You could not keep a supply of donors standing by at the front lines waiting to be tapped. The solution came from a series of discoveries about anticoagulants, substances that prevent blood from clotting. In 1914, researchers found that sodium citrate, a simple chemical compound, could keep blood liquid for hours outside the body. You could draw blood from a donor, mix it with citrate, store it in a glass bottle, and transfuse it later. Not much later. The blood was still perishable, but hours instead of minutes changed everything. By 1917, a Canadian doctor named Lawrence Bruce Robertson was performing transfusions on wounded soldiers behind the front lines using stored citrated blood. A British Army officer named Oswald Hope Robertson, no relation, established the first blood depot near the front, storing type O blood in ice-cooled containers and rushing it forward when casualties arrived. This was, in effect, the world's first blood bank, though the term would not be coined for another 20 years. The results were dramatic. Men who would have bled to death on the stretcher were saved. Surgeons who had been forced to amputate limbs for lack of blood could now replace what had been lost and attempt to repair the damage instead. The difference between life and death, between keeping a leg and losing one, came down to a bottle of someone else's blood, properly typed, properly stored, properly delivered. But the war also revealed the limits of what was known. Despite Landsteiner's discovery, blood typing was still crude. The Roth factor had not been discovered yet. Reactions that could not be explained by ABO incompatibility continued to occur, baffling doctors who thought they had matched the blood correctly. Soldiers who received properly typed transfusions sometimes developed fevers, chills, kidney failure. Some died. The doctors knew they were missing something. They just did not know what. The Second World War accelerated everything. The scale of the conflict was so vast, the number of casualties so enormous, that blood transfusion became not just a medical procedure, but a logistical operation of staggering complexity. The Allied powers organized nationwide blood drives collecting millions of units from civilian donors. The blood was processed, typed, stored, and shipped across oceans, packed in ice, delivered to field hospitals in North Africa, Italy, France, the Pacific. The entire system had to work perfectly every time, or people died. And it was during this massive wartime effort that the RS factor, discovered in 1937 but not yet widely understood, suddenly became critical, because the ROS factor was causing transfusion reactions that ABO typing alone could not prevent. A soldier typed as A positive could receive A positive blood and still have a reaction if he had been sensitized to other blood group antigens through previous transfusions or, in the case of women, through pregnancy. The system was more complex than anyone had realized. Much more complex. By the end of the war, blood banking had become a science unto itself. The International Society of Blood Transfusion was established. Standards were developed for typing, storage, and compatibility testing. The cross-match test, which mixed donor blood with recipient blood before transfusion to check for reactions, became standard practice. And the ROS factor was incorporated into routine typing, doubling the number of blood type categories and dramatically improving the safety of transfusions. But here is what I find most fascinating about this wartime history. The science of blood was driven not by curiosity but by desperation. Every major advance in our understanding of blood types, blood storage, and blood compatibility was made under conditions of extreme stress, when the cost of failure was measured not in retracted papers or lost grants, but in dead soldiers. The peaceful laboratory work of Landsteiner and his colleagues laid the foundation, but the building was constructed by combat medics and military surgeons working with inadequate equipment under enemy fire, trying to keep broken bodies alive long enough to reach a hospital. This is a pattern that repeats throughout the history of medicine. War drives innovation, not because war is good, it is not, but because war is good, but because war creates problems so urgent and so massive that peacetime methods cannot solve them. The need for blood during 2 world wars transformed a laboratory curiosity into a global life-saving system that now processes over 100 million units of blood per year worldwide. And that system, for all its sophistication, still depends on the same basic principle that Landsteiner discovered in 1901. You have to match the blood. We have to know what type the donor is and what type the recipient is, and you have to make sure they are compatible. The ABO system, the R system, and dozens of other antigen systems that have been discovered since, each one adding another layer of complexity, another variable that has to be checked, another way that a transfusion can go wrong. This is where the modern significance of RA-ino-centrificance of Rh-negative blood becomes most visible. Not in theories about ancient astronauts or Basque genetics, but in the emergency room, in the trauma bay, in the operating room where a surgeon is trying to save a life, and the blood bank is running low on the one type that can safely go into anyone. O negative, the universal donor. I need to explain why O negative blood is special, because the reason reveals something important about the entire blood type system. Your immune system is constantly scanning your body for foreign invaders. It does this by reading the molecular tags on the surface of every cell it encounters. Your own cells carry tags that your immune system recognizes as self. Foreign cells carry tags that your immune system recognizes as not self. When it finds a not self tag, it attacks. Blood type antigens are among the most prominent of these tags. If you are type A, your red blood cells carry A antigens, and your immune system has pre-formed antibodies against B antigens. If someone gives you type B blood, your anti-B antibodies latch onto the B antigens on the donor's red blood cells and trigger a massive immune response. The donor cells clump together, blocking blood vessels. The clumps are attacked and destroyed, releasing their contents into your bloodstream. Your kidneys try to filter the debris and fail. Your blood pressure drops. Your organs begin to shut down. You can die within minutes. Type O blood has no A antigens and no B antigens. Entry-negative blood has no D antigen. Put them together and you get O-negative, blood that carries almost no foreign tags at all. To most immune systems, O-negative red blood cells are essentially invisible. They slip past the defenses. They deliver their oxygen without triggering an attack. They are not truly universal. There are other minor antigens that can occasionally cause problems, but they are the closest thing we have to blood that works in any human body on Earth. This makes O-negative blood the default choice in emergencies when there is no time to type the patient. Car accident, gunshot wound, massive hemorrhage during surgery, any situation where minutes matter and the patient's blood type is unknown. The doctors reach for O-negative. Every time. And here is the problem. Only about 7% of the global population has O-negative blood. In some regions the number is even lower. Demand is constant and high. Supply is limited and fragile. Blood has a shelf life. Red blood cells can be stored for about 42 days before they degrade beyond usefulness. Plasma can be frozen and kept for a year. Platelets last only 5 days. This means that the blood supply is not a stockpile. It is a river. A constant flow of donations coming in and transfusions going out. If the donations slow down, the river drops. If the demand spikes, the river drops faster. And when the river drops too low, the O-negative shelf empties first, because O-negative is used first. For every emergency, for every unknown patient, for every situation where there is no margin for error. Blood banks live in a state of perpetual anxiety about O-negative. They track their inventory in real time. They send out alerts when supplies drop below critical thresholds. They call their regular O-negative donors not with casual reminders but with urgent appeals, because they know that somewhere in the next 24 hours someone is going to come through the emergency room doors bleeding from a wound that will kill them if they do not get blood in the next 10 minutes, and that blood has to be O-negative because there is no time to find out what type they really are. If you are O-negative, you may already know this. You may have received those calls. You may have felt the quiet weight of knowing that your blood is disproportionately valuable to the medical system, that your donation has a higher probability of going directly into a trauma patient than anyone else's. It is not a superpower in the comic book sense. You cannot fly or see through walls. But in the pragmatic, unglamorous life and death world of emergency medicine, your blood type is as close to a superpower as biology gets. And if you are not O-negative, your blood is still needed. Every type matters. Every type saves lives. The system only works if all types are available in sufficient quantities, and shortages of A-positive or B-negative or AB anything can be just as critical for the patients who need those specific types. The universal donor myth, useful as it is, can obscure this basic truth. The blood supply is an ecosystem. Every type is a species. Remove any one of them and the whole system becomes fragile. But the story of blood in modern medicine is not only about emergencies and transfusions. It is also about something more subtle and more interesting. It is about what blood types can tell us about disease. For most of the 20th century, doctors assumed that blood types were medically irrelevant beyond transfusions and pregnancy. Your type was A or B or O, positive or negative, and that was that. It affected what blood you could receive and what risks your pregnancy might face, but otherwise it did not matter. Your blood type did not make you more or less likely to get cancer or heart disease or diabetes or any other condition. Then the studies started appearing, small at first, scattered, easy to dismiss as statistical artifacts. But they kept coming, and the pattern, when it emerged, was unexpected. People with type A blood seemed to have slightly higher rates of certain cancers. Stomach cancer, pancreatic cancer. The association was small but consistent, appearing across multiple studies in multiple countries. People with type O seemed to have slightly lower rates of these cancers but slightly higher rates of peptic ulcers. People with type B showed different patterns in different diseases. And everywhere researchers looked, blood type seemed to be nudging the odds, gently, subtly, not enough to determine anyone's fate, but enough to show up in the statistics. The Rho factor entered these studies later. Some research suggested that Rh-negative individuals might have slightly different immune responses to certain pathogens. A few studies found correlations between Rh status and susceptibility to toxoplasmosis, a parasitic infection carried by cats that is far more common than most people realize. Other studies looked at R status and mental health, finding tentative correlations with anxiety, depression, and reaction time, though these results were inconsistent and difficult to replicate. Then came COVID-19. In 2020, as the pandemic swept across the world, researchers turned to blood types almost immediately. Early data from China and Europe suggested that people with type A blood might be slightly more susceptible to severe COVID-19, while people with type O might be slightly more protected. The associations were weak but statistically significant in some studies. The Rho factor generated its own wave of interest. Several analyses found that Rh ethyltonetuglav and tebuterol seemed to have a slightly lower risk of infection or severe disease. The effects were small, much smaller than the effects of age, obesity, or vaccination status. But they were there, flickering at the edge of statistical significance, like a candle in a draught. The scientific community responded with appropriate caution. These are observational studies, not controlled experiments. Correlation is not causation. The associations could be driven by confounding factors that researchers have not controlled for. The blood type effect, if it exists, is small enough that it should not influence anyone's behavior or medical decisions. And yet, there it is. Another thread connecting blood type to something larger. Another hint that the molecular tags on the surface of your red blood cells are not just labels for the blood bank. They are doing something, interacting with something, affecting something, in ways that we are only beginning to detect and cannot yet explain. This is the frontier, not the emergency room with its urgent drama, though that is important, not the blood bank with its perpetual anxiety, though that is real. The frontier is here, in these quiet studies, in these tentative correlations, in these faint signals that blood type matters in ways we do not understand. That the ABO system and the race system are not just relics of ancient evolutionary pressures but active participants in your health, your immunity, your vulnerability to the diseases that circulate through the modern world. What are they doing? Why are they there? What purpose do they serve? These questions, first raised by Landsteiner's discovery in 1901, are still unanswered. A century of research has given us the ability to type blood instantly, to transfuse it safely, to store it and ship it and fractionate it into components, but it has not given us the fundamental answer. We do not know why blood types exist. We have theories. The best one involves pathogens. The idea is that different blood type antigens interact differently with different infectious agents, bacteria, viruses, parasites. A pathogen that uses the A antigen as a gateway to infect cells would have a harder time infecting someone with type B or type O blood. Over time, natural selection would maintain diversity in blood types because no single type would be optimal against all pathogens. This is called frequency-dependent selection, and it is a well-established mechanism in evolutionary biology. But this theory, elegant as it is, remains largely unproven for the ABO system and almost entirely untested for the RI system. We do not know which pathogens selected for which blood types. We do not know whether the selective pressures are still active, or whether they operated in the distant past and are now irrelevant. We do not know whether the subtle disease associations we are finding today are echoes of ancient selection or new developments. And for Rh-negative blood specifically, the pathogen theory faces a special challenge. Because whatever advantage Rh-negative blood might provide against pathogens, it has to be strong enough to overcome the reproductive cost of hemolytic disease. It has to be worth more than the babies it kills. And so far no one has identified a pathogen whose selective pressure on the ART system is strong enough to clear that bar. This is the impasse. The place where the corridor splits into too many branches and the light does not reach far enough down any of them. We can see the shape of the mystery. We can describe its dimensions. We can list the hypotheses and evaluate the evidence and acknowledge the gaps. But we cannot solve it. Not yet. And maybe that is the most honest thing I can tell you tonight. That the blood flowing through you right now, the most ordinary, most essential, most taken for granted substance in your body, is also one of the least understood. That science, for all its magnificent achievements, still stands at the shore of your blood like a traveller standing at the edge of an ocean, able to see the surface and map the coastline, but unable to plumb the depths. Let me take you to one more place before we move on. A place that seems at first glance to have nothing to do with blood types or genetics or evolution. A place that is entirely human, entirely cultural, entirely constructed from belief and imagination and the ancient need to make sense of the world. The history of what blood means. Not what it is, not its biochemistry or its genetics or its medical applications. What it means. Because humans have been assigning meaning to blood for far longer than they have been studying it. And those meanings, layered and contradictory and deeply embedded in our cultures, shape how we think about blood even now. Even after Landsteiner, even after the Rand factor, even after everything science has taught us. Blood means kinship. Blood relative, bloodline, blood is thicker than water. These phrases are so familiar that we barely notice them anymore. But they encode an ancient belief that family relationships are carried in the blood, that something essential passes from parent to child through this specific fluid, that the bond between blood relatives is stronger and more fundamental than any other human connection. This belief predates genetics by thousands of years. People did not know about DNA or chromosomes or alleles. They did not know that inheritance was carried in molecules too small to see, but they observed correctly that children resembled their parents. That certain traits ran in families, that certain retardats many in families, that something was being transmitted from one generation to the next, and they located that something in the one substance that visibly flowed from parent to child. Mothers bled during childbirth. The umbilical cord pulsed with blood. The connection was obvious. Blood was the vehicle of heredity. Blood carried the family essence forward through time. This belief had profound consequences. If blood carried the family essence, then blood purity mattered. Mixing your blood with the wrong family, the wrong tribe, the wrong race could corrupt the essence and weaken the line. This is where the concept of noble blood originated. The idea that certain families carried something in their blood that made them inherently superior, that their blood was literally different from the blood of common people. Purer, finer, more refined. We know now that this is wrong. Blood types do not correlate with nobility or virtue or intelligence. The blood of a king is biochemically identical to the blood of a peasant. The same hemoglobin, the same plasma proteins, the same hemoglobin, the same plasma proteins, the same white blood cells and platelets. Whatever differences exist, whatever subtle variations in antigen profiles or immune responses, they have nothing to do with social status or moral worth. But the myth of noble blood persisted for centuries, and it had real consequences. It justified aristocratic privilege. It supported racial hierarchies. It underpinned colonial ideologies that divided humanity into categories based on supposed blood purity, and used those categories to justify conquest, enslavement, and genocide. Blood libel, the false accusation that Jewish people used the blood of Christian children in religious rituals, was used to justify persecution and murder for hundreds of years. The language of blood purity was central to the ideology of the Third Reich. I am not telling you this to make a political point. I am telling you this because it illustrates something important about the relationship between science and myth, the same substance that Landsteiner studied in his quiet Vienna laboratory, the same substance that combat medics used to save lives on the beaches of Normandy, the same substance that flows through you right now. That substance has also been the vehicle for some of the most destructive ideas in human history. The science of blood and the mythology of blood are intertwined in ways that cannot be separated, and understanding one without the other gives you an incomplete picture of both. Because here is the truth that the mythology gets right, even when it gets everything else wrong. Blood does connect us, not in the mystical way that the myths suggest, but in a way that is equally profound. Your blood type is an inheritance. It was passed to you by your parents, who received it from theirs, in an unbroken chain stretching back through every generation that has ever lived. The A antigen on your red blood cells, if you have it, is the same A antigen that existed on the red blood cells of your ancestors who lived 30,000 years ago. The RASADEAT deletion, if you carry it, has been travelling through your family line for tens of thousands of years, surviving every catastrophe, every migration, every bottleneck, every plague, every war. In that sense, your blood really does carry the family essence, not a mystical essence, a genetic one, a molecular one, but an essence nonetheless, a connection to the past that is as real and as physical as the iron atoms in your hemoglobin. And here is something else that the mythology gets right, though again in a different way than it intends. Blood really is special, not because it is sacred or divine or magical, but because it is the one substance in your body that touches everything else. Your blood reaches every organ, every tissue, every cell. It carries oxygen from your lungs to your brain. It carries nutrients from your gut to your muscles. It carries waste products from your cells to your kidneys. It carries hormones from your glands to their targets. It carries immune cells from your bone marrow to wherever they are needed. It is the postal service, the highway system, the communication network, and the garbage collection all in one. No other substance in your body does all of this. No other substance is this versatile, this essential, this connected. If you wanted to find one substance that represents the whole organism, one fluid that integrates every system and sustains every function, blood is the obvious choice. The ancients who looked at blood and saw life itself were not wrong. They were just using a different vocabulary for a truth that modern science has confirmed in exquisite molecular detail. And tonight, as you lie here in the dark, your blood is doing all of this. Right now. Without your permission. Without your awareness. Without any effort on your part. 5 liters of it, circulating through 100,000 kilometers of blood vessels, making a complete circuit of your body roughly once every minute, picking up oxygen, dropping it off, picking up waste, dropping it off, fighting infections, repairing damage, maintaining the temperature and the chemistry and the pressure that your cells need to function. It has been doing this since before you were born. It will continue doing it until you die. And in between, it will carry you through every experience you will ever have, every thought, every emotion, every dream, all of it sustained by this ancient, essential, mysterious liquid that you almost never think about. But I want you to think about it now, just for a moment. Feel your heartbeat, that steady rhythm in your chest, that pulse in your wrist or your neck or your temple. That is your blood moving. That is the sound of 5 liters of mystery being pumped through a network of vessels that, if laid end to end, would wrap around the earth 2.5 times. And within that blood, sitting quietly on the surface of every red blood cell, are the molecular tags that determine your type. The A or B antigens, or neither, or both. The D antigen, or its absence. These tiny molecular structures, too small to see even with a powerful microscope, determine whether a transfusion will save your life or kill you. They connect you to populations that lived 10,000 years ago on the other side of the world. They carry information about ancient diseases and ancient migrations and ancient catastrophes that shaped the human species into what it is today. and nobody fully understands why they are there. Now I want to tell you about something that happened in the 20th century that most people have never heard of, and that reveals a side of the blood type story that is both disturbing and deeply important. It is the story of blood and race, and it is a story that shows how easily scientific discoveries can be twisted into tools of oppression. When Landsteiner published his blood type paper in 1901, the scientific community was fascinated. Here was a measurable, objective, biological difference between people. Not skin color, which was subjective and graded and culturally loaded. Not skull shape, which was crude and unreliable. Blood type. Something you could test in a laboratory with a few drops of blood and a few drops of serum. Something that gave you a clean, unambiguous result. A or B or unambiguous result. A or B or O. No room for interpretation. No room for bias. Almost immediately, researchers began testing blood types across different populations, and almost immediately they found differences. Different populations showed different frequencies of A, B, and O. Europeans had higher frequencies of A. Asian populations had higher frequencies of B. Indigenous Americans had very high frequencies of O. The differences were real, measurable, reproducible, and almost immediately people began misusing the data. Because in the early 20th century, the concept of race was not yet understood as the social construct that modern genetics has shown it to be. Race was considered biological, real, fundamental. Scientists, many of them well-intentioned, many of them brilliant, looked at the blood type data and saw what they expected to see. Evidence of deep, essential biological differences between racial groups. Some went further. They tried to rank the races based on blood type. The Hirschfeld classification, developed during World War I by Ludwig and Hanke Hirschfeld, who tested thousands of soldiers from different ethnic backgrounds, mapped blood type frequencies onto a global scale and divided humanity into biochemical races based on the ratio of type A to type B. The implication, sometimes stated explicitly, sometimes merely suggested, was that the races with more type A blood were more evolved, more civilized, more advanced. This was bad science dressed up in laboratory coats. The blood type differences between populations are real, but they tell you almost nothing about the individuals within those populations. Within any population, you find all blood types. A European can be type B, an Asian can be type A, an Indigenous American can be type A or B if they have any European ancestry at all. The population-level differences are statistical tendencies, not boundaries. More importantly, the blood type differences between populations are tiny compared to the genetic similarities. Two people of different races who share the same blood type are more similar to each other, immunologically speaking, than two people of the same race with different blood types. The blood does not respect racial boundaries because racial boundaries, as biology understands them, do not exist. They are cultural constructions mapped onto a continuous gradient of human genetic variation. But the damage was done. The idea that blood types could be used to classify races persisted for decades. It fed into eugenics movements. It provided a veneer of scientific respectability to ideologies of racial supremacy. It contributed in small but real ways to the intellectual climate that made the horrors of the 20th century possible. And the Roe factor, when it was discovered, added another layer. Because Rh-negative blood was most common in European populations and rare or absent in African and Asian populations, it was easy to construct a narrative in which Rh-negative blood was somehow more evolved, more European, more special. This narrative persists today in certain corners of the internet, dressed up in the language of genetics but carrying the same old cargo of racial hierarchy. I want to be absolutely clear about this. There is nothing superior or inferior about any blood type. There is nothing more evolved or less evolved about Rh-positive or Rh-negative blood. These are variations within a single species, maintained by evolutionary processes that have nothing to do with intelligence, morality, or human worth. The blood of every human being on Earth is made of the same components, serves the same functions, and carries the same fundamental information. The differences are real, but they are differences in detail, not in kind. The history of blood type research is a cautionary tale about what happens when science is used to confirm prejudices rather than to challenge them. It is a reminder that data does not interpret itself. that the same facts can be used to support opposite conclusions depending on the assumptions you bring to them, and that the most dangerous pseudoscience is the kind that looks like real science, that uses real data, real methods, real laboratories, to reach conclusions that are fundamentally, catastrophically wrong. This matters now more than ever, because the internet is full of blood-type theories that recycle these old ideas in new packaging. Theories that certain blood types are more evolved, that RS-negative blood marks a special lineage, that blood type determines personality, intelligence, or spiritual destiny. Some of these theories are harmless, some of them are not, and the difference between harmless speculation and dangerous ideology can be very thin. But I did not bring you here tonight to lecture you about the misuse of science. I brought you here to tell you a story about the most common substance in your body and the most uncommon mysteries it contains. And the story is not over. Because there is one more mystery we need to explore, one more question that keeps researchers awake at night, and that, when you hear it, will change the way you think about every drop of blood that has ever flowed through a human vein. The question is this: what is the ARSH system for? Not what does it do in a medical context. We know that. It determines transfusion compatibility and pregnancy risk. But what is it for? What purpose does the D antigen serve? Why does it exist? What function does it perform on the surface of a red blood cell that is important enough for evolution to have maintained it across hundreds of millions of years of mammalian evolution? Because the D antigen is not just sitting there doing nothing. It is part of a protein complex that spans the membrane of the red blood cell. It has a three-dimensional structure that is precisely folded and precisely positioned. It interacts with other proteins in the membrane. It does something. But what it does is still not entirely clear. Some researchers believe it plays a role in maintaining the shape and flexibility of red blood cells. Red blood cells are remarkably deformable. They can squeeze through capillaries that are narrower than their own diameter, bending and folding like tiny rubber discs. This flexibility is essential for oxygen delivery. If red blood cells were rigid, they would get stuck in the smallest capillaries, and the tissue downstream would be starved of oxygen. The REITs protein complex may help maintain this flexibility, acting as a kind of molecular scaffold that gives the cell membrane its characteristic elasticity. Others believe the R-complex plays a role in transporting ammonia across the cell membrane. Ammonia is a waste product of metabolism, and it needs to be removed from cells efficiently to prevent toxic build-up. Some evidence suggests that the Roche proteins function as ammonia channels, allowing the molecule to pass through the membrane in a controlled way. If this is true, it would explain why the RH system is so ancient and so universal. Ammonia transport is a fundamental cellular function. Every living cell needs to manage its ammonia levels. A protein that helps with this task would be under strong selective pressure to be maintained. It would be too important to lose. And yet 15% of humans have lost it. Or at least, they have lost the D antigen, the specific variant that determines ARCH positive or negative status. The rest of the ARCH protein complex is still present in ARCH negative individuals. They are not missing the entire system, just one piece of it. But that one piece, the D antigen, is the piece that causes all the problems. The piece that triggers hemolytic disease. The piece whose presence or absence determines your RORH type. Why would evolution allow this one piece to be deleted in 15% of a population if it serves an important function? Either the function is redundant, meaning other proteins can compensate for the loss, or the deletion provides some countervailing benefit that we have not identified, or the deletion happened recently enough that evolution has not had time to fully select against it, or there is something else going on, something we have not thought of yet. Some function of the D antigen that we are not testing for because we do not know to test for it. Some interaction with some environmental factor that has changed since the deletion first occurred. Some piece of the puzzle that is still lying face down on the table waiting for someone to turn it over. I keep coming back to this image. A puzzle with most of the pieces in place. The picture is almost visible. You can see the outlines. You can identify the major shapes. But there are gaps, small gaps scattered across the image where pieces are missing. And without those pieces, the picture remains incomplete, suggestive, tantalizing, but not quite readable. That is where the science of blood stands tonight. Not in ignorance, not in confusion, but in that particular state of informed uncertainty that is the most productive and most frustrating place a scientist can be, knowing enough to ask the right questions, not yet knowing enough to ask them in. And so the blood keeps flowing, through the Basques in their mountains, and the Berbers in their deserts, and the emergency rooms of every hospital in the world, through you, right now, as your eyes grow heavy and your mind begins to soften, and the words on the screen or in your ears start to blur at the edges. Your blood does not need you to understand it. It does not need you to solve its mysteries or answer its questions. It just needs you to lie still and breathe and let it do its work. It has been doing this work for 300,000 years, since the first anatomically modern human drew breath on the African savanna. It has carried oxygen through ice ages and heat waves. It has fought off infections that have no names because the people who carried them left no records. It has flowed through the veins of your grandparents and your great-grandparents and their grandparents and their grandparents and their great-grandparents, all the way back to a time before language, before fire, before tools, and it will keep flowing after you fall asleep, steady, patient, ancient, reliable. The oldest technology you own, the most essential system in your body, the one thing that connects every cell, every organ, every thought, every breath, every heartbeat into a single continuous process that we call being alive. You do not need to understand it to benefit from it. You do not need to solve the mystery to be part of it. You just need to be here, breathing, listening, letting the blood do what it has always done. And that is enough. That has always been enough. The story continues. But you can rest now. The blood will keep its vigil while you sleep. It has been doing this since before you were born. It will not stop tonight. It will not stop tonight. It will keep circulating, keep carrying, keep sustaining, keep connecting every part of you to every other part in a silent, continuous act of devotion that asks nothing in return except that you keep breathing. So keep breathing, slowly, deeply, steadily, like the blood itself, flowing without effort, moving without thought, carrying you forward through the night toward the morning that is already forming somewhere on the other side of the world. The mystery will still be there when you wake up. It has been there for 80 years. It will wait one more night. Sleep now. The blood will keep. And still you are here, still breathing, still listening, still carried along by the same current that has been moving through this story since the beginning, the current of blood, the current of time, the current of questions that keep multiplying the deeper you go. And we are deep now. We have travelled through centuries of discovery and millennia of mythology. We have stood in Landsteiner's laboratory and watched him mix blood samples on a cold Vienna morning. We have knelt beside combat medics on the battlefields of 2 world wars. We have climbed into the Pyrenees with the Basque people and their impossible language and their impossible blood. We have stared at the pregnancy paradox and asked how evolution could create something so self-defeating. We have traced the bottleneck that nearly erased our species and wondered whether Rh-negative blood is a scar or a shield. But there is one more corridor we have not walked down, one more door we have not opened. And behind it is something that I think about more than anything else in this entire story. Something that is not about science at all, or rather, something that is about what science cannot reach. The part of the blood story that lives not in laboratories or textbooks, but in the minds of the people who carry it. The psychology of blood. Because here is something that no genetic analysis or population study can fully explain. Millions of people around the world feel something about their blood type. Not think, feel, a deep, pre-rational, almost visceral sense that their blood means something, that it connects them to something larger than themselves, that it contains information not just about their biology, but about their identity, their purpose, their place in the human story. I have read thousands of comments and messages from people who discovered their Rh-negative status, and felt for the first time in their lives that something about themselves made sense. People who had always felt different, who had always felt like they did not quite belong, who had walked through their lives with a low-grade sense of alienation that they could not name or explain. And then they found out about their blood type, and suddenly there was a category, a label, a tribe of people who felt the same way they did. The scientific part of my brain wants to explain this away: confirmation bias, the Barnum effect, the human tendency to see patterns in noise and meaning in randomness. All of these are real cognitive biases that distort our perception. All of them can explain why people feel a connection to their blood type that goes beyond the biological reality. But the human part of my brain, the part that listens to these stories and hears the emotion in them, that part is not so quick to dismiss, because the need to belong is not a cognitive bias, it is a fundamental human drive, as fundamental as hunger or thirst. We are social primates. We evolved in small groups where belonging meant survival and exclusion meant death. The need to be part of something, to feel connected, to know that you are not alone in whatever makes you different, that need is not irrational. It is as rational as breathing. And if blood type provides a framework for meeting that need, if it gives people a language for talking about their sense of difference and a community of people who share it, then maybe the specific accuracy of the framework matters less than the function it serves. Maybe the question is not whether Rh-negative blood really makes you more intuitive or more sensitive or more anything. Maybe the question is why so many people need it to. I do not have an answer to that question. I'm not sure anyone does, but I think it is worth sitting with. Worth letting it settle into the silence between your thoughts as you lie here in the dark. Because the story of blood is not just a story about molecules and antigens and evolutionary pressures. It is a story about what it means to be human, about the lengths we will go to in order to understand ourselves, about the stories we tell when the science runs out. And the science always runs out eventually. Not because science is inadequate, but because the questions keep getting bigger. You solve the transfusion problem and the blood type question appears. You map the blood types and the Roche mystery appears. You trace the Roche distribution and the bottleneck question appears. You model the bottleneck and the question of selective advantage appears. And behind that question another, and another, and another. Each answer opening a new door onto a new darkness that the light has not yet reached. This is the nature of knowledge. It does not fill the void. It illuminates the edges of the void and reveals how much larger the void is than you thought. Every discovery shows you how much more there is to discover. Every answer shows you how many more questions there are to ask. And the most profound mysteries are not the ones we cannot answer. They are the ones we cannot even formulate yet. The questions we do not know how to ask because we do not yet have the concepts or the language or the instruments to perceive what we are looking at. Blood is full of those questions. Questions that live in the spaces between what we know and what we can measure. Questions that will require not just better microscopes and faster computers, but new ways of thinking about biology, about evolution, about the relationship between genetics and identity, about the meaning of variation within a species. And in the meantime, the blood keeps flowing. Indifferent to our questions, unconcerned with our theories, doing what it has always done. Carrying oxygen, fighting infection, maintaining life. Connecting every cell in your body to every other cell in a continuous circuit that has not been interrupted since the moment your heart first started beating. Sometime around the 22nd day after your conception, when you were smaller than a grain of rice and your blood vessels were being laid down for the first time, following a blueprint that is 300 million years old, let me tell you about something beautiful. Something that happens inside you every single second of every single day and that you have never once been aware of. Your bone marrow is making blood right now. Not occasionally, not when you need it, constantly, every second. Your bone marrow, that spongy tissue inside your larger bones, is producing roughly 2 million new red blood cells per second. 2 million per second. Each one precisely shaped, precisely sized, precisely loaded with hemoglobin, precisely tagged with the molecular markers that determine your blood type. each one launched into your bloodstream to begin a journey that will last about 120 days before the cell wears out and is recycled by your spleen. 2 million per second. That means by the time you finish listening to this sentence, your body has produced about 10 million new red blood cells. By the time you fall asleep tonight, it will have produced roughly 200 billion. 200 billion cells, each one a tiny marvel of biological engineering, each one carrying the same blood-type antigens, the same hemoglobin molecules, the same genetic legacy that your ancestors carried across continents and through catastrophes and into the present. This production never stops. It cannot stop. If it stopped for even a few days, your existing red blood cells would age and die faster than they could be replaced, and you would become anemic, weak, oxygen-starved. Your bone marrow is the most productive factory in your body, and it operates around the clock without maintenance, without supervision, without any input from your conscious mind. You do not have to think about making blood. You do not have to remember to make blood. You do not have to try to make blood. It just happens. Automatically. Relentlessly. The deepest and most essential process in your body, running silently in the background while you worry about your job and your relationships and what to have for dinner. And every single one of those 2 million cells produced per second carries your blood type. The A or B antigens or their absence. The D antigen or its absence. The D antigen or its absence. These molecular tags are not painted on after the cell is made. They are built into the cell membrane during production, encoded in the DNA of the stem cells in your bone marrow, expressed as proteins that are assembled and inserted into the membrane as the cell matures. Your blood type is not a label. It is a structural feature, as fundamental to the cell as its shape or its hemoglobin content. And this is what I find most amazing about blood types. They are everywhere in your body, but they are invisible. You cannot see them. You cannot feel them. You cannot detect them without laboratory equipment. They affect your health, your reproductive options, your compatibility with other humans, and yet they operate entirely below the threshold of conscious awareness. You carry them with you every second of your life, and you never notice them until something goes wrong, until you need a transfusion, until you become pregnant, until someone mixes your blood with the wrong type and your immune system erupts in a reaction that can kill you within minutes. Then suddenly your blood type matters more than anything else about you, more than your name, more than your age, more than your medical history. The first question the emergency room asks is not who are you, it is what type are you. There is something deeply strange about this, about carrying within you a characteristic that is simultaneously life-defining and completely invisible, that can save your life or end it depending on circumstances that you cannot control, that connects you to populations that lived thousands of years ago and to strangers who might save your life tomorrow, all through a molecular tag on the surface of a cell that you will never see. And it makes me wonder what else we carry that we cannot see. What other invisible characteristics shape our lives in ways we do not perceive? What other ancient inheritances are coded into our cells, influencing our health, our behavior, our vulnerability to disease, our compatibility with other humans? Without our knowledge or consent, the genome is full of these invisible legacies, thousands of genes that affect thousands of traits in ways that we are only beginning to map. Some of them are well understood. Eye color, hair texture, lactose tolerance. Others are mysterious. Why do some people have perfect pitch? Why are some people natural athletes? Why do some people never get seasick? The answers are somewhere in the genome, coded in molecular structures as invisible and as consequential as blood-type antigens. And underlying all of it, connecting all of it, flowing through all of it, is the blood. The medium, the messenger, the river that connects every organ to every other organ, every other cell to every other cell, every moment of your life to every other moment. The blood does not just carry oxygen and nutrients, it carries information, hormones that regulate your mood and your growth and your sleep. Immune cells that remember every pathogen you have ever encountered, proteins that signal inflammation and repair and danger, and somewhere in all of that biochemical noise, patterns that we have not yet learned to read. I sometimes think that blood is the closest thing we have to a physical manifestation of time. Not clock time. Biological time. The time that your body keeps. The circadian rhythms that tell you when to sleep and when to wake. The hormonal cycles that regulate growth and reproduction. The aging process that changes the composition of your blood from birth through childhood, through adulthood, through old age. Your blood at 20 is different from your blood at 60. Not in type. Type does not change. But in composition, in the balance of cells and proteins and hormones, in the information it carries. Your blood is a diary. A real-time record of everything your body is experiencing, has experienced, and is preparing to experience. Doctors can read parts of that diary. A blood test can tell them whether you are fighting an infection, whether your liver is functioning properly, whether your blood sugar is under control, whether you are pregnant, whether you are predisposed to certain diseases, whether you are dehydrated or malnourished or anemic, but they can only read the parts they know how to read, the parts they have developed tests for, the parts that fit into existing medical categories. There is almost certainly more information in your blood than we currently know how to extract. Patterns and signals and correlations that will only become visible as our analytical tools become more sophisticated and our understanding of biochemistry deepens. Future doctors may look back on our era the way we look back on the era of bloodletting, with a mixture of respect for what was achieved and horror at what was missed. They may wonder how we could have had the blood right there, flowing through every patient, carrying all that information, and failed to read most of it. They may marvel at our primitive tests and our crude categories, and our inability to see what, to them, will seem obvious. And that is fine. That is how progress works. Every generation builds on the ignorance of the last. Every breakthrough reveals a new horizon of ignorance beyond it. The story of blood is the story of slowly learning to read a language that is older than language itself. We have deciphered a few words. We can make out the general topic, but the full meaning of the text remains beyond us, for now. Now let me tell you about the future of blood, because the story we have been following tonight does not end with the discovery of blood types or the development of transfusion medicine or the mapping of the rice system. Those are chapters, important chapters, but the book is still being written. The next chapter is already taking shape in laboratories around the world, and it involves something that would have seemed like science fiction just a few decades ago. Synthetic blood. The idea is simple. Instead of relying on human donors whose blood is perishable and whose supply is unpredictable, what if we could manufacture blood in a factory? What if we could grow red blood cells in bioreactors? The way we grow bacteria in fermentation tanks or yeast in breweries? What if we could produce unlimited quantities of any blood type on demand, without donors, without collection, without the perpetual anxiety of running out? The technology is not there yet, but it is getting closer. In 2022, researchers in the United Kingdom performed the first transfusion of laboratory-grown red blood cells into human volunteers. The cells were grown from stem cells donated by volunteers, cultured in nutrient-rich media, and allowed to mature into functional red blood cells in laboratory flasks. The transfusion was small, just a teaspoon or two, designed to test safety and survival of the cells in the body. But it worked. The lab-grown cells survived. They circulated. They carried oxygen. They did what red blood cells are supposed to do. This is a first step, a proof of concept. The distance between a teaspoon of lab-grown blood and a full unit suitable for emergency transfusion is enormous. The cost of growing red blood cells in the lab is currently thousands of times higher than the cost of collecting them from donors. The scale-up challenges are immense. But the principle has been demonstrated. And here is where Rh-negative blood becomes relevant in a completely new way. Because one of the most exciting possibilities of synthetic blood is the ability to engineer the surface antigens. If you are growing red blood cells from stem cells, you can potentially modify the genes that determine blood type before the cells mature. You could create cells that lack all major antigens, cells that are invisible to any immune system, cells that are truly universally compatible. No A antigens, no B antigens, no D antigens, no D antigen, No Kell or Duffy or Kidd or any of the dozens of minor antigens that can cause transfusion reactions. In other words, you could create the perfect O-negative blood. Better than O-negative actually, because natural O-negative blood still carries some minor antigens that can occasionally cause problems. Engineered blood could be stripped of everything. A blank slate, a ghost cell that slips past every immune defense and delivers its oxygen without triggering any response at all. This is the end game. Not just for Rh-negative blood, but for the entire blood type system. If synthetic blood becomes practical, the ancient molecular tags that have shaped human health and human history for millions of years will become irrelevant. The blood type categories that Landsteiner discovered in 1901 will become medical curiosities, artifacts of a time when we depended on other humans for the blood that saved our lives. Your blood type, which tonight carries all this mystery and history and significance, will become as medically irrelevant as your eye color. But that is a long way off. Decades, maybe generations. In the meantime, the blood supply still depends on donors, on human beings who walk into a clinic and sit down and roll up their sleeves and allow a stranger to insert a needle into their arm and draw out a pint of the most essential substance in their body. Voluntarily, without payment in most countries, motivated by nothing more than the abstract knowledge that somewhere, someone they will never meet might need what they are giving away. I find this extraordinary. Not the science, though the science is remarkable, the human behavior. The fact that millions of people around the world regularly donate a piece of themselves, literally, to sustain the lives of strangers. This is not an instinct. No evolutionary pressure selected for voluntary blood donation. It is a cultural achievement, a moral invention, a decision, renewed every time a donor walks through the door to participate in a system of mutual aid that our ancestors could not have imagined. And for Rh-negative donors, especially O-negative donors, that participation carries extra weight, not moral weight, logistical weight, because their blood is needed more urgently and more frequently than other types, because the shelf is always running low, because the next emergency could be tonight. If you are Rh-negative and you have never donated blood, I am not going to tell you that you should. That is your decision, your body, your choice. But I will tell you this, your blood is rare, it is needed, and every pint you give has a higher than average chance of going directly into someone who is dying. Someone whose life depends on the very molecular absence that makes your blood special. That is not a superpower. That is something better. It is a fact, a simple, verifiable, life-saving fact. And unlike the theories about psychic abilities and ancient astronauts and noble bloodlines, this fact does not require belief. It does not require faith. It does not require you to accept anything on insufficient evidence. It is real. It is measurable. And it saves lives. But enough about the future. Let me bring you back to the present, to this moment, to this breath, to this heartbeat. Because the story of blood is ultimately not a story about science or history or genetics or medicine. It is a story about you, about the liquid that is flowing through you right now, as it has flowed through every human being who has ever lived, about the ancient, invisible, essential substance that connects you to your parents and your grandparents and their grandparents, all the way back through every generation to the very first human being who ever drew breath. Your blood is an inheritance. The most literal inheritance you will ever receive, more literal than a house or a savings account or a piece of jewelry. Your blood type was determined at the moment of your conception, written into your DNA by the combination of your parents' genes, and it will not change for the rest of your life. It is the one thing about you that is absolutely permanent, absolutely fixed, absolutely certain, and it connects you to everyone who shares it. Every other A-positive person on Earth, every other B-negative person, every other O-positive person, every other AB anything. These are your blood siblings, not in the familial sense, but in the biological sense. You share something with them that you do not share with people of other types. A molecular identity, a biochemical handshake that your cells recognize and accept, and it connects you to the past. to the ancient populations whose migrations and catastrophes and random genetic accidents determined which blood types would be common and which would be rare, to the Ice Age survivors in the Pyrenees, to the Neanderthals who lived in European caves for 200,000 years before our ancestors arrived, to the bottleneck survivors who carried humanity through its darkest hour, to every generation that survived every plague and every famine and every war and every disaster that could have ended the human story but did not. Your blood is the receipt for all of that survival, the proof that your ancestors made it, every single one of them, through everything, without exception. Because if any one of them had not survived, you would not exist. Your blood type, your specific combination of A or B or O, positive or negative, would never have been assembled. The particular molecular tags on your particular red blood cells would never have been expressed. You would not be here, lying in the dark, listening to this story, breathing this air, feeling this heartbeat. But you are here, and that means that the entire unbroken chain of human survival, stretching back 300,000 years or more, has culminated in this moment. In you, in the 5 liters of ancient mystery that are keeping you alive right now. And I think that is worth knowing. Not because it makes you special, though in a sense it does. Everything about you is the product of 300,000 years of relentless, improbable, magnificent survival. But because it puts your daily worries into perspective, whatever you are stressed about, whatever kept you awake tonight, whatever problem seems insurmountable, your ancestors faced worse, much worse, and they survived. The blood in your veins is the proof. Now let me tell you one last thing, one more piece of the blood story that I have been saving for the end, because I think it is the most important piece of all. We have been talking tonight about what divides blood, what makes types different, what makes one type incompatible with another, the antigens that trigger immune reactions, the antibodies that attack foreign cells, the molecular differences that can mean the difference between life and death in a transfusion. But I have not talked enough about what unites blood, about the things that are the same in every single human being on Earth, regardless of type, regardless of race, regardless of nationality, regardless of anything. The hemoglobin is the same. Every human being, whether they are A or B or O, positive or negative, carries the same hemoglobin molecules in their red blood cells. The same iron atoms grabbing the same oxygen molecules and releasing them in the same way. The chemistry is identical. The function is identical. The protein structure is identical. The white blood cells are the same. The immune system that protects you from infection operates on the same principles in every human body. The same types of white cells, the same signaling molecules, the same mechanisms of defense. The details vary, which is why some people are more susceptible to certain diseases than others. But the basic architecture is universal. The platelets are the same, the clotting factors are the same, the plasma proteins are the same. The basic biochemistry of blood, the stuff that keeps you alive moment to moment, is identical across all 7 billion humans on the planet. The differences that we've been talking about tonight, the ABO antigens, the Rye factor, the minor blood group systems, these are variations on a theme, tiny molecular decorations on the surface of cells that otherwise function in exactly the same way. If you took a drop of blood from every human being on Earth and stripped away the antigens, removed the molecular name tags, reduced each sample to its fundamental components, you would not be able to tell them apart. They would all look the same under the microscope. They would all perform the same functions in the test tube. They would all tell the same basic story. The story of oxygen and iron and hemoglobin and survival. The things that divide us are real. They matter medically. They matter historically. They matter scientifically. But they are small. Tiny variations in surface chemistry on cells that are otherwise identical. Molecular footnotes on a text that is, in its essential message, the same in every human being who has ever lived. We are the same blood. Literally, biochemically, fundamentally, the same red river flowing through different bodies, the same ancient inheritance carried forward by different families, The same oxygen delivered to different brains that use it to think different thoughts and dream different dreams and wonder about the same mysteries. I do not know why blood types exist. I do not know what purpose the R system serves. I do not know why 15% of humans carry a blood type that defies evolutionary logic. I do not know whether the answer will come next year or next century or never. But I know this. Whatever the answer turns out to be, it will not change the fundamental truth that your blood reveals, that underneath the variations, underneath the types and the antigens and the immune reactions, we are one species, one family, one bloodline in the most literal sense, connected by chemistry and history and the stubborn, beautiful, improbable facts that we are all still here, still breathing, still circulating, still carrying the oxygen that our brains need to ask the next question and dream the next dream and tell the next story in the dark. And that brings us to the end of this particular story. But it is not really an end. The blood does not end. The questions do not end. The mystery does not end. They continue flowing the way blood continues flowing, around and around in a circuit that has no beginning and no ending, only the steady, patient, ancient rhythm of a heart that refuses to stop. Your heart is beating right now. Can you feel it? That gentle pulse in your chest, that rhythm that started before you were born and has not missed a beat since. That is the sound of your blood moving, the sound of your survival. The sound of 300,000 years of human history compressed into a single ongoing moment. And if you have enjoyed following this river of history and mystery tonight, if the story carried you somewhere peaceful or somewhere interesting or somewhere you did not expect, then I would ask you only this. Leave a small mark, a thumbprint on the cave wall. A like is enough. Just a quiet signal that you were here, that you listened, that you followed the blood trail into the dark and found something worth finding. And if you want to tell me where in the world you are listening from tonight, I would love to know. Not because it matters in any scientific sense, but because there is something deeply moving about the thought that right now, at this exact moment, someone in Buenos Aires and someone in Helsinki and someone in a small apartment in Tokyo are all lying in the dark, listening to the same words, feeling the same heartbeat, wondering about the same mysteries. That is a kind of transfusion too, not of blood, of something else, of curiosity, of wonder, of the ancient human need to understand what we are made of and where we came from and why we are here. If you want to be here the next time we follow a mystery into the dark, subscribe. That way you will know when the next story is ready, when the next candle is lit, when the next candle is lit, when the next campfire is burning and the next tale is being told, because there are so many more stories to tell, so many more ordinary things that turn out to be extraordinary when you look at them closely enough, so many more hidden histories and unsolved mysteries and quiet revelations waiting in the most familiar corners of everyday life. There are other stories on this channel right now. Stories about ordinary things that contain extraordinary histories. About the objects and substances and systems that you encounter every day without ever wondering how they got here or what they mean. Stories designed exactly like this one. To carry you gently from wakefulness into rest. To fill the quiet hours with something that feeds your curiosity without demanding your attention. To be there for you on the nights when your mind is too busy and your thoughts are too loud. And you need something, anything, to focus on. That is not the thing that is keeping you awake. Those stories are waiting for you, whenever you need them, whenever the night feels too long, whenever the dark feels too empty. They will be there, glowing softly on the screen, ready to take you somewhere you have never been. But that is for another night. Tonight is complete. The story of blood has been told. From the sacred rituals of ancient Egypt to the quiet laboratories of modern Vienna, from the battlefields of 2 world wars to the emergency rooms of tonight, from the genetic bottleneck that nearly erased our species, to the tiny molecular tags on the surface of your red blood cells that nobody can fully explain, from the first terrified human who watched their own blood spill and wondered what was leaving them, to the future scientist who will grow perfect blood in a glass flask and make the entire mystery of blood types a footnote in a medical textbook that nobody reads anymore. All of it flowing, all of it connected, all of it leading here, to this moment, to this breath, to this heartbeat, to you. You are the latest chapter in a very old book, a book written in red, a book that has no author and no ending, a book that is being written right now, in the language of hemoglobin and iron and oxygen and time, by the 5 litres of ancient mystery that are keeping you alive. And those 5 litres do not care about theories or mysteries or unanswered questions. They do not care about your blood type or your ancestry or your place in the genetic history of the human species. They care about one thing only, keeping you here, keeping you breathing, keeping you alive long enough to see another morning. And they are very good at it. They have been practicing for 300,000 years. So let them work. Let them do what they do. Let the blood flow and the heartbeat and the oxygen arrive where it needs to arrive. You do not need to supervise. You do not need to help. We do not need to do anything at all except lie here and breathe and let the oldest system in your body carry you through the night. The blood will keep. It always keeps. Through every darkness, through every silence, through every mystery, through every night, and tomorrow when you open your eyes, it will still be there, still flowing, still carrying, still keeping you alive, still holding in its ancient molecular structure secrets that we may never fully understand. But that is tomorrow, and tomorrow is a long way away. For now, there is only this: the dark, the quiet, the heartbeat, the steady, ancient, patient flow of blood through a body that has earned its rest. Sleep now. The blood will keep until morning, and the morning will come. It always does. Good night.